Hello guys, upon request I decided to make a video about solving this problem. This kind of problem is very integrated. It is likely to appear in an exam. It's a very good problem. It incorporates a lot of properties that we don't use that often. First, let's look at the first question, question A. So it asks us to find the phase of the xj omega. First, we look at this x signal. It is not symmetric. It just needs to shift to left by 1, and it will be a perfect symmetric signal. Therefore, let's make it shift to left by 1. We might as well call it yt a new signal. And yt is real and even. So from our property, we know its Fourier transform will be real and even. This is from our property. So if we write the Fourier transform in the polar form, we will be able to see that because it's real and even, so this part will goes away, will become 1. How to make it become 1? That means the phase of yj omega needs to be 0. And using the time shifting property, which is used very commonly in signals and system, is I shifted to left by 1 times xj omega. We might as well write xj omega in polar form so we can compare the magnitude and the phase with yj omega. We want to write it in polar form, j omega plus. So notice this. This signal is equals to this signal. That means the magnitude have to be equal and the phase have to be equal. Therefore, we know the phase have to be equal, and we know since yj omega is real and even, so the phase is 0. Therefore, we can know the phase of xj omega. For question B, we used our analysis equation. Recall what our analysis equation is? This is our analysis equation. And if we plug in 0 to omega, we get what we want, which is the area under the curve. This red area. For question C, we use the synthesis equation. Recall the synthesis equation. I know all those equations are on the form that our professor gave us, but for these kind of common equations, it's better to remember it. It will be quicker when you answering questions during exam. Oh, I'm sorry. I left the negative sign here. So this is the synthesis equation. If we plug in t equals 0 in here, it will also make the exponential function go away, and we're able to get forgot the 1 over 2 pi. This happens. X j omega d omega. And this is what we want. And let's skip question D first. Question E is Parseval relation. Just use the equation of Parseval relation. Should be able to do the trick. And now we look at question E. First of all, question D. If we look at this giant equation, we may be scared by it, but don't worry. This thing inside the integral, we can consider it as some signal hj omega. It is some signal the variable omega, right? So this thing became hj omega d omega. Which is what we just proved in question C, is 2 pi times h0. So our goal is to find ht. To find ht, we have to find hj omega first. To find hj omega, we use the convolution properties. Recall what convolution property is? It's when you do convolution of xt and yt, you're actually doing the multiplication in the frequency domain. Isn't that looks familiar? xj omega, yj omega. Then this will be our new yj omega. So let me write it here. Yj omega will just be a sinc function with a time shift. So from the basic Fourier transform pair, we know this sinc function have an inverse Fourier transform, which is from -1 to 1 with a magnitude of 1. And we know this part is just a time shifting. You can see how common the time shifting was used in our homework. So be very sensitive to exponential e to the j something omega, this kind of form. So this is time shifting to the left by 2. And now I can draw my y function. I know it shifted to left by 2, right? So it became -3 to -1 with a magnitude of 1. Now I have my yt, and I already have my xt over here. What's our next goal? We find our yt, we find our xt. Next we do convolution, right? So we want to do the convolution of xt and yt with t equals 0. Notice this part. don't do the convolution for xt and yt first. I mean, you could do it, but it's gonna take a lot of time calculating all the interval, and mistakes might happen along the way. So be smart and look at this condition here, t equals 0. And go back to the definition we learned about convolution. X tau, ht minus tau, d tau, when t equals 0. So I might as well just plug in t equals 0 to this t over here. So I get this. So what is our h negative tau? Oh, I'm sorry. Here's y. We have our yt. So y negative tau shouldn't be hard from 1 to 3 with a magnitude of 1. And notice this, when we do the multiplication of x tau and y tau, we actually get this part of the signal, which is a part of signal of signal xt. And we're doing integral on this signal. If you want to write it mathematically, it will be from 1 to 3 did that on x tau, because the magnitude of y negative tau is 1, which is the area underneath this part. So our problem becomes really easy. It's just 2 pi times the area, the yellow area. So this sub-problem seems kind of intimidated, but if we break it down by parts, and as long as we know what we want, like we have a goal, we want to find ht first. To find ht, we need to find hj omega, which is the Fourier transform of ht. To find hj omega, we notice that it is actually a signal xj omega multiplied by another signal. We can just call it yj omega. So we know the properties of convolution to get us ht back using inverse Fourier transform. So we're trying to find our xj omega times yj omega. What did it look like? What's its inverse Fourier transform? And then we do convolution using the basic convolution definition, the integral of x tau and yt minus tau, and we get our answer. For the last question, question F, is actually just the property of an even-odd decomposition of a real signal. We can see this xt is real, right? Because you can plot it. And the property of a real signal is this even part doing a Fourier transform. You get the real part of xj omega, and the odd part do the same thing. You get j imaginary part of xj omega. What we're gonna use here is definitely, like, we know the real part of xj omega, and it asks us to find the inverse Fourier transform, which is just the even part of the signal. So you find the x negative t, what does it look like, and you sum xt and x negative t together, and then divide it by half, and you will be able to get your answer.